Okay, we're going to go over the derivative of a trig function and its tangent. Okay. So we have our function here, and what we'll be looking for is the equation of the tangent at x is equal to pi over 2. So we'll be working in radians in this question. Because we're looking for the equation of a tangent, we need to find the rate of change at this specific point, which means we need to derive our original function. So this, again, becomes a product rule. F prime x, we take the derivative of x, which is the value of 1, multiplied by cos 2x, plus our original x, times the derivative of 2x. Well, cos 2x derives into negative sine 2x times 2, right? We derive the function within. So we end up with negative sine 2x times 2. So we have now cos 2x plus 2x, negative 2x, sine 2x. We have this all here. Does this look right? I think we're okay. Okay. Now in this question, why does this look funny? Oh, that's why it looks funny. I've written a lot of these here. So we have cos 2x minus 2x sine 2x. There we go. So from this function, we have our derivative here. And what we're going to want to do in this question is we're going to want to set this equal to 0. We want to find values that are equal to 0 here. I feel like something's gone funny here. We'll set it equal to 0. Something is very odd here. Sorry, I'm so used to trying to set things equal to 0 to find critical points. That's not what we're doing in this question. Finding our point at when x is equal to pi over 2. I knew something looked funny. So, I apologize. But here's our derivative. What we're going to do from here, our f prime x, is we're going to be looking at f prime at pi over 2. So we're plugging in pi over 2. So we have cos 2 times pi over 2 minus 2 times pi over 2 times sine 2 times pi over 2. We'll simplify what we have here. This becomes cos of pi minus pi times sine of pi. So if we remember our sinusoidal functions, hopefully we do. We don't. We have 0. Pi over 2 is our 90. Pi is our 180. 3 pi over 2 is our 270. And 2 pi being our 360. Our sine wave goes up to the value of 1. Comes back down, goes down to the value of negative 1 and 0. This is our sine wave. Okay. And our cos wave starts at 1. Follows the same pattern, but is a little different in its values. So, using this information, cos, which is our red one, cos pi, so cos at pi is the value of negative 1. Okay, that's where we equate to negative 1. So cos pi is the value of negative 1 minus pi times sine pi. Well, sine at pi, it's the black one, is a value of 0. So pi times 0. Pi times 0 is 0, which means this equates to negative 1 as our slope. So if we're looking for the line of the tangent, y is equal to negative 1x plus b, we need to have a y and an x value. So we'll take our original equation, which is x cos 2x, x cos 2x. We know our x value was pi over 2, so we need to find a y value. So we get pi over 2 times cos 2 times pi over 2, which means we have pi over 2 times cos pi we already solved. It becomes a value of -1, which means our y value at this point is negative pi over 2. So we'll replace our y with negative pi over 2 and our x with pi over 2. So negative pi over 2 is equal to negative pi over 2 plus b. This means our b is 0, which means the equation of our line is y is equal to negative x, just our slope.